Hey everyone, I'm Shah. This is the second video in a larger series on AI agents. Here I'm going to talk about an essential feature of agentic systems, which is giving LLMs access to tools. I'll start by discussing how this works under the hood, then share a concrete example of building a simple YouTube video agent using OpenAI's new Agents SDK. AI agents give us a new way of thinking about software. For example, if we were building a traditional software system to do, say, customer support, it might look something like this. We'll have a customer query come in, then we might devise some clever rules or business logic to categorize this message. This could be categories like it's a password inquiry, a billing inquiry, account inquiry, and then so on with the long tail of things that customers ask about. And then within each of these categories, again, we might have another set of categorizations that need to happen to get even more fine-grained on what the question is actually getting at. Then for each of these fine-grained examples, let's say we have like a pre-canned solution that we can generate and pass back to the user interface. While this can account for the vast majority of questions, because typically there's usually just a handful of very common issues that come up like 70 or 80% of the time, there are a few limitations with building a software system like this. For one, it's very inflexible. So it's going to work really well on the common issues, but again, there's going to be this long tail of things that customers ask about, which may not work so well with this software system. And if you want to account for this long tail of inquiries, you're going to have to come up with some clever rules once again, which takes time and energy and money. However, if we were to try to solve this problem using an AI agent, it would look somewhat different. Instead of meticulously defining all the common questions and pre-writing solutions to all of these things, we might just take a user's query, pass it to an LLM, and rather than predefining responses for this system, we might do the following. So we may give the LLM context through company onboarding documents for customer support specialists. We might give it access to a document search tool that will allow the LLM to generate queries and search over known FAQs and support documentation. And then maybe we'll also give the LLM access to a tool to escalate issues to human support. Two of the key benefits of this AI agent are, one, it's a very flexible system. It's not going to be so rigid in that it can only process a handful of popular issues. It can go pretty far into this long tail of inquiries that customers might come up with. But perhaps most strikingly is how simple this solution design is. With the traditional software system, you can imagine this very complex chain of logic, if-else statements, and workflows. But with the AI agent, we're just bringing together a handful of key components. So this highlights the key difference between traditional software and building agentic systems. In traditional software, you have to explicitly define every single step of the solution and implement it into code. However, for agentic systems, the mindset shifts into just curating the right tools and giving it to an LLM so it can solve the problem on its own. And so tool use plays a central role in agentic systems, but we might wonder to ourselves, how does this actually work? The trouble is that LLMs on their own cannot use tools. They are simply text generators. Given a sequence of tokens, they simply predict the most likely next tokens. So in order to get these models to use tools, we have to wrap LLMs with some code. This involves three basic steps. First, we need to monitor an LLM's outputs to see if it's trying to make a tool call. So this can involve just some regex check or string matching to see if a sequence of tokens or a special token is generated in the LLM's output. Next, if we find a stopping token or a sequence of tokens, we can pause the generation and then execute whatever tool call the LLM was trying to do. And then this is going to be done with some separate code. And then finally, we can capture the response of that tool call and inject it back into the context of the model. So to give a concrete example of this, let's say this is the raw text that the LLM is operating on and is generating text from. So just to break this down step by step, let's say we start with a system message where we tell the LLM you are a helpful assistant that can use tools when needed. So we're just letting it know that it can use tools. Next, we have a user query. So the user might ask something like, what's the weather in Dallas? Then we might have the assistant recognize that it needs to use a tool. So it says, oh, to answer that, I need to get the current weather in Dallas, calling weather. So it's going to use this get weather tool with location equal to Dallas. So this is it realizing it needs to use a tool. And then whether it was fine-tuned for tool calling or there was some other prompting involved outside of the system message, the LLM knows to use these special tokens or these special strings to demarcate its tool calling. And then the tool call has this special JSON format where you have these key value pairs. So the tool call involves a name. So we're going to use the get weather tool, and that get weather tool takes in a set of arguments. So in this case, it's just one argument called location. And for the location, we're going to input Dallas, and then that's the end of the tool call. So this is something predefined. This is something generated by the user. This is generated by the LLM. This is also generated by the LLM. But once we see this special tool call end token, we can pause generation, pass the Dallas input to this get weather function, which let's say is implemented in Python. We can run that code, get the output, and then manually inject this text into this context. We can add this system message that says results from get weather. It's 72 degrees Fahrenheit and sunny in Dallas, and then end. Then from here, we can relinquish control back to the model and then have the model generate the rest of its output. While this is just a toy example, the specific special tokens used is going to depend on the model you're working with. The structure of this tool calling is going to depend on the specific model or the way you're implementing the tool usage. And still, there's no single standard. Different model providers will fine-tune their models slightly differently, and people might also hack non-fine-tuned models to do tool use in weird and interesting ways. But hopefully this example gives you a better idea of what this looks like under the hood. But a key question here is, how does the LLM know how to do this? How does it know to do tool call and then generate a JSON formatted text like this and end the tool call? Really, there are two ways to pull this off. The first way is simply prompting the model, just telling the model that it has access to these tools and give it instructions on how to use those tools. So here's one example. We can just simply describe the tools. Here's our system message. You are a helpful assistant that can use tools when needed. You have access to the following tool. Calculator evaluates simple math expressions like 5 times 4 plus 2. How to use tools. So now we're giving it instructions. If you need to make a tool call, respond only in the following format: tool call start, tool call end. So notice here we didn't put a JSON format, but this is how we're telling the model it can use the tools. So this is going to require us to continuously monitor the outputs of the model and check for this end token or special string of /tool call. We know when the model generates this, it's trying to run this function, so we can write some extra code to implement that, and then we can inject the output into this conversation. So this is how a lot of people implemented tool use over the past 18 months, 12 months or so. They simply just took these LLMs off the shelf. They were instruction tuned, so they know how to follow instructions, but they weren't specifically fine-tuned for tool use. So the way they kind of tricked the model or got the model to use these tools is by doing a lot of prompting and writing some extra code to implement this. However, over the past 6 to 12 months or so, this has gotten much more straightforward because now we have these fine-tuned models specifically for function calling, and many of which are available via APIs like OpenAI, Anthropic, Mistral, Together AI, and the list goes on. In these cases, we don't actually need to put anything into the system prompt. We don't need to give any explanations. All we need to do is provide this JSON schema for each tool that we want to provide to the model. This is going to include things like the type. So let's say it's a function, it has a name, it has has a description, it has some input parameters, it has other properties that have some special meaning in the particular API that you're using. And so this might be different depending on the API provider, but they all take some kind of JSON input, which allows you to define how these functions work. Since these models are specifically fine-tuned to use tools, there are two key benefits in using them via these APIs. First is that the API automatically passes the tool info to the model. So there's really no need to include a description in the system message, because based on however they fine-tuned the model, they devised some specific structure or format for passing this information to the model. The second handy feature of using these fine-tuned models via an API is that the API will automatically stop inference whenever it's time to execute a function call. If you're streaming from Anthropic's API, it's going to stop and it's going to give you a stop reason of tool use, and then your software, your code that you're running can know that Anthropic stopped streaming tokens to me because the model wants to call a tool. Let me see what tool it wants to call. Okay, let me run that code. Okay, let me get the output, and then let me pass that output back into the context in whatever way that I want to do that. So this is the most practical way of doing it, and then this is what you're going to do 99% of the time. However, there is another way to use tools with LLMs. So basically, there may be situations where you have a lot of tools, or maybe you have very esoteric tools where models out of the box don't really understand how to use them effectively, especially if multiple tools need to be chained together. If deciding what tools to use in of itself is a complicated problem to solve, the model might need some additional training, some additional guidance on how to use them effectively. So at a high level, what this is going to involve is to gather a bunch of examples of the complicated and or specialized tool calls and use that to fine-tune the LLM, whether that's a model that's already been fine-tuned for tool use, or maybe it's just a LLM fine-tuned for instruction following. But of course, this is an order of magnitude more sophisticated and requires more effort than just simple prompting. But if you want to get a flavor of how to do this, reference number 1 is really nice. It's a talk all about fine-tuning LLMs for tool use. So if you're curious, you can check out that video. Here, I want to make things more concrete by giving a specific example. I want to use OpenAI's Agents SDK to create a very simple YouTube video agent. What this is going to involve is simply getting an LLM and giving it access to a single tool, which allows it to transcribe YouTube videos based on a link provided by the user. So let's just walk through this code. First, I'm going to import a few things. I'm going to use this YouTube transcript API, which allows you to transcribe YouTube videos easily. Then I'm going to import regex for extracting video IDs from YouTube links. Then I'm going to import a bunch of stuff from the Agents SDK. So this agent class, this function tool decorator, runner allows us to run agents, item helpers allows us to keep track of all the events that come out of the agent, and then run context wrapper. I guess we'll see what that does. I don't remember off the top of my head. Then we're importing this submodule from OpenAI's library. So this response delta event. So this will allow us to stream tokens, so we don't have to wait until the LLM generates all of its response to print it to the user. We can stream it one token at a time. And then I'm importing this .env library, which allows you to create a .env file to import environment variables. So this is just how I'm going to import my OpenAI secret key. I have a .env file where I have my secret key stored, and then this function will import it into my Python environment. And then finally, I'll import async IO, which will allow us to do some asynchronous stuff, which we'll talk about later. OpenAI in their Agents SDK defines an agent as an LLM equipped with instructions and tools. So let's define those things. Our instructions will be very simple. You provide help with tasks related to YouTube videos, nothing fancy. Then we're going to define the tool. This is going to be more involved. And one really great feature of the Agents SDK is that you can easily turn any Python function into a tool by adding this function tool decorator to it. What this does is by putting this on top of our function, the Agents SDK will automatically parse the function name, the inputs and its types, the output type, and the doc string to automatically construct that JSON schema we saw earlier for doing function calling via OpenAI's API. So we don't have to write that complicated and confusing JSON schema. We can just write Python code that we're comfortable with and automatically turn any function into a tool. So my tool here is actually very simple. It'll extract the transcript with timestamps from a YouTube video. It takes in a YouTube video URL, then it returns the transcript with the timestamps in the minute, second format. Here we're going to do like a regex search to extract the video ID from a input URL, and then if this matching process fails, we can raise an error. Then we can just extract the video ID like this, and then once we have the video ID, we can extract the transcript using this YouTube transcript API. It has this get transcript method, which is passing the video ID, and then what we're going to do is extract the text from the transcript. And so this transcript object is going to be a list of dictionaries. So we have entry, which is a dictionary, transcript is a list, and then we're just going to extract the start time, and we're going to format it in minutes and seconds, and then we're going to extract the text. We're going to format it as this string with the timestamp and then the text, so the transcript from that specific timestamp. And then we're just gonna put all this into a list, and then we'll just do .join to format this list as a single string. And then if anything goes wrong, we can throw an error. Okay, so we now have our instructions and we have our tool. So we have all the ingredients we need to make an AI agent. To make an agent with this Agents SDK is very simple. We just need to give it a name, give it instructions, and give it tools. And then OpenAI has a default LLM it uses for the agents class. It's going to be one fine-tuned for function calling and following instructions. That's what I'm using here, but you can additionally specify whatever model you want to use as well. Everything we've done up until this point was actually very straightforward. Writing the instructions were trivial, the function was very straightforward, and then making the agent was trivial. However, now this is where the code gets a bit trickier, and a big part of that is these agent systems are going to be asynchronous, meaning that they're not going to run in a predefined sequence of steps. This is important first and foremost for streaming tokens from an LLM, because for example, if you were to interact with an LLM synchronously, that would mean you make an API call and then you wait, you get a response from the LLM, and then you do the next step in your process. However, LLMs can take quite a long time to generate tokens, so it's much better to stream the tokens in real time, but this is going to require you to write your script in an asynchronous way. So basically what's going to happen is you're going to make your API call, and instead of waiting for all the tokens, you'll just grab some of the tokens, then you'll display those tokens to the user, then you'll go back, grab some more tokens, and then you'll display those. So you can kind of task switch between grabbing tokens and displaying tokens to the user. Additionally, this is helpful with agents doing tool calls themselves, where they might be calling an API and now you're waiting for like a weather API to get back to you. So instead of just holding up your entire application, waiting for these other processes to run, you can write it in an asynchronous way and allow the user to interrupt the agent. Like you can allow your code to do other things while it's waiting for these tasks to happen. So that's just like a long-winded way of saying that running the agent is going to be the most sophisticated part of this example. So here I just implemented a very simple command line interface. So we're going to write a function called main that will allow us to interact with this agent in the terminal. I'm initializing this list to have like input items. So these are the messages we'll pass to the LLM. And the first first thing we'll do is we'll print a few lines. So we'll introduce the application, we'll introduce the agent as a YouTube transcript agent. We'll tell the user that it can type exit to end the conversation, and then we'll give it some instructions. Ask me anything about YouTube videos. And then we'll have this while loop going where we'll allow the user to type in an input. So we'll display you, and then the user can type something in. Then we'll capture that input as user input, and then we'll append it to this input items. So this list of dictionaries with all the messages we're going to give to the LLM. Then we'll check if the user typed in exit, quit, or buy. And then if it does, we'll break out of the while loop. If not, we'll just keep going. Also, if the user doesn't type anything, we'll just kind of go back and see if the user wants to type something else. But if the user types something, we can go to the agent. We can print the agent, and then we can have this runner.runStreamed method running. So here we're actually running the agent. So we have this agent running and we're passing it these inputs. The inputs are going to be so far whatever the user typed in, and the agent is what we defined on the previous slide. Here there are a bunch of events we can check for and do different things based on them. And the code's getting cut off here, but it's all on the GitHub repository. But basically in this first one, we're just seeing if we're getting tokens as the next event in this stream. If we are getting tokens, we're going to print those. But then other important events are a tool call. So if the LLM uses its one tool, which is fetching the transcript, we'll just print that to the user interface. Then if the event is the output of a tool call, we can append this transcript to the context. So we can add this as a system message. It's getting cut off, but we're adding it as a system message. Then we're saying transcript fetched. And then this last one, this is the entirety of the output from the LLM. And then we can just add this to our input items as the assistant. So this role that is getting cut off is assistant. And then this is just the response from the model. So a few things are happening here. We're handling not just like the back and forth conversation between the assistant and the user, but we're also incorporating these tool calls. So we're doing things when the tool gets called, and we're adding the transcript to the context via the system message. Additionally, we're going to be streaming tokens using this like response delta, which is also getting cut off. And then we're going to print a new line after the assistant response. And so this is all pretty complicated, and maybe you don't even have to implement this yourself. Maybe you're just building a UI with Gradio or Streamlit or something like that, and this doesn't really matter. But once we have this function, we can just simply have this async io.run main. This will spin up the terminal if we're running this as a Py file. However, if you're running this in Jupyter Lab, it's already running this for the Jupyter Notebook UI. So you can just simply write await main, and then this is going to add it to the event loop for the async functionality. But just to give you guys a demo, this is the display text. So YouTube transcript agent, type exit to end the conversation, ask me anything about YouTube videos. Here I'm asking it if it can summarize this video, and then that's the link from my previous video in the series. And then it just goes off and summarizes it. It does a really good job. It talks about the 3 levels of agency I talked about, and it summarizes the thing. So it says deeper discussions, practical implementations and following videos. That's good. And now I'm asking, okay, so we got a summary. Now let's get chapters. So this is really cool. Automatically, it's figuring out the chapters and just skimming this. This is doing a pretty good job. Usually it takes me like a few minutes, or it can actually be pretty long if I'm trying to write timestamps for a podcast that I've done, but using a tool like this would make it very fast. And then what's cool is that it automatically links to each of these timestamps. So you can actually click on these in the terminal to jump to that point in the video. And then finally, I have it write me a LinkedIn post summarizing all the key design patterns I talked about in the previous video. It's a simple agent, but this was me just like cracking open the Agents SDK. It's quite a practical use case for me as I make a lot of YouTube videos and like repurpose content from it. But I guess there are things already from like Google with Gemini that you can probably do stuff like this out of the box. But as a technical person and builder, I always love building stuff myself. Okay, so what's next? Here we did a pretty simple example. This is probably like the most basic system that someone might still call an agent, but there is a key limitation to basically just let's curate all the components and rely on the LLM to solve the problem for us. And the limitation is that these systems may behave in unpredictable ways. So they're very capable because they can potentially solve problems on their own, and you don't really have to be involved and use your own brain power to do that. But this comes at the cost of predictability. However, we can kind of balance these two things of predictability and capability through so-called agentic workflows. So I discussed this briefly in the previous video, but these days, most practitioners I talk to, when they talk about building AI agents, they're really thinking about agentic workflows. So not just having a single LLM doing everything, but rather you have multiple LLMs perhaps chained together. These LLMs can have access to tools, basically what we built here, but integrated into a larger software system. And so the upside of agentic workflows is that you can have these guardrails and evals built into the system to make sure that it doesn't go off the rails. So this is going to be the main focus of the next video in this series. So I hope this video was helpful. If you have any questions, please let me know in the comment section below. And as always, thank you so much for your time and thanks for watching.